Artificial intelligence is rapidly transforming our world. From self-driving cars to personalized medicine, AI promises to revolutionize countless aspects of our lives. However, this transformative technology also presents profound risks. One of the most pressing concerns is AI bias, a phenomenon where algorithms replicate and amplify existing societal prejudices. AI systems are often touted as objective and impartial. After all, they rely on data and mathematical models, not human emotions. Yet this perception of objectivity is misleading. AI systems are only as unbiased as the data they are trained on and the humans who design them. When these inputs are flawed, the consequences can be devastating. This essay delves into the complex issue of AI bias. We will explore its definition, examine its root causes, and expose its real-world consequences. By understanding the origins and impacts of AI bias, we can begin to develop strategies to mitigate its harms and ensure a more just and equitable future for all. AI bias occurs when an algorithm systematically produces outcomes that are unfair to certain groups of people. This bias is not a matter of machines developing prejudices independently. Instead, it stems from the data used to train AI systems and the human decisions embedded in their design. Imagine an AI system used for hiring. If the system is trained on data that reflects historical gender bias in a particular industry, it might learn to associate men with leadership positions. Consequently, the algorithm could unfairly penalize female applicants, perpetuating the cycle of discrimination. AI bias is particularly insidious because it often operates subtly. Algorithms can perpetuate discrimination without explicit instructions to do so, simply by identifying and replicating patterns of inequality present in the data. This hidden nature makes AI bias challenging to detect and even more difficult to eradicate. The consequences of AI bias can be severe. In areas like criminal justice, healthcare, and finance, biased algorithms can lead to unfair sentencing, unequal access to care, and discriminatory loan practices. As AI systems become increasingly integrated into our lives, it is crucial to understand and address the issue of bias, ensuring that these powerful technologies do not exacerbate existing inequalities. At the heart of AI bias lies a fundamental misunderstanding of the relationship between correlation and causation. AI systems excel at identifying correlations in data. They can find patterns and relationships that humans might miss. However, correlation does not equal causation. Just because two things are correlated does not mean one causes the other. For example, an AI system might find a correlation between zip code and creditworthiness. People living in certain zip codes might be statistically more likely to default on loans. However, this correlation likely reflects underlying socioeconomic factors, such as historical discrimination in housing or access to financial services. Mistaking correlation for causation can lead to biased outcomes. If an AI system uses zip code as a proxy for creditworthiness, it could unfairly penalize individuals from disadvantaged backgrounds, even if they have a strong credit history. Addressing AI bias requires moving beyond simple correlations. We must develop AI systems that can understand the causal relationships between different factors and account for the complex social and historical contexts that shape our world. This requires careful data selection, algorithmic design, and ongoing monitoring to ensure that AI systems do not perpetuate harmful stereotypes. AI bias can arise from various sources, often intertwined and mutually reinforcing. Understanding these sources is crucial for developing effective strategies to mitigate bias and promote fairness in AI systems. Data bias. The most prevalent source of AI bias is biased data. If the data used to train an AI system is unrepresentative or reflects historical prejudices, the algorithm will learn and perpetuate these biases. For instance, facial recognition systems trained on datasets predominantly composed of light-skinned faces have been shown to perform poorly on darker-skinned faces, leading to misidentification and discrimination. Algorithmic bias. Bias can also be introduced through the design of the algorithm itself. This can occur through the choice of features used to train the model, the way data is pre-processed, or the objective function the algorithm is optimized for. For example, an algorithm designed to maximize profit in loan applications might inadvertently discriminate against certain groups if those groups are underrepresented in the training data, or if historical lending practices have disadvantaged them. Human bias. AI systems are created and deployed by humans, and human biases inevitably influence these processes. Unconscious biases among developers can impact data selection, model design, and evaluation metrics. Furthermore, decisions about where and how AI systems are deployed can introduce or amplify bias. For example, the use of predictive policing algorithms, often trained on data reflecting racial disparities in arrests, can reinforce discriminatory policing practices. Systemic bias, AI bias, does not exist in a vacuum. It is deeply intertwined with broader societal inequalities and systems of oppression. Historical discrimination, economic disparities, and cultural prejudices all contribute to the data that AI systems are trained on and the context in which they are deployed. Addressing AI bias requires confronting these systemic issues and working towards a more just and equitable society. These sources of AI bias highlight the complex and multifaceted nature of the problem. Effectively mitigating AI bias requires a holistic approach that considers all stages of the AI lifecycle, from data collection and model development to deployment and ongoing monitoring. Section 5. AI bias in action, real-world examples of algorithmic discrimination. The consequences of AI bias are not hypothetical. They are playing out in various sectors, impacting people's lives in profound ways. Here are just a few documented examples of AI bias in action: facial recognition. In 2019, a study by the National Institute of Standards and Technology, or NIST, found that facial recognition algorithms exhibited significant racial and gender bias. The study revealed that these systems were much more likely to misidentify Black and Asian faces compared to white faces, particularly Black women. Such inaccuracies have led to wrongful arrests, highlighting the urgent need for greater scrutiny and regulation of this technology. Hiring and recruitment: AI-powered hiring tools, which promise to streamline recruitment processes, have also been shown to perpetuate gender and racial bias. One prominent example is Amazon's scrapped recruitment tool, which reportedly downgraded resumes from women and applicants from specific demographic groups, demonstrating how AI can reinforce existing inequalities in the workplace. Loan applications and credit scoring AI-driven lending algorithms, used by banks and financial institutions, have come under fire for amplifying historical biases in credit scoring. These algorithms can perpetuate discriminatory practices like redlining, denying loans, or charging higher interest rates to individuals from disadvantaged backgrounds, even when controlling for creditworthiness. Criminal justice. One of the most controversial applications of AI is in the criminal justice system. Algorithms like Compass, used to predict recidivism risk, have been shown to exhibit racial bias, assigning higher risk scores to Black defendants compared to white defendants with similar criminal histories. Such biased assessments can influence sentencing, parole decisions, and perpetuate systemic inequalities within the justice system. Healthcare. Even in healthcare, where AI holds immense promise for improving patient outcomes, bias poses a significant concern. Algorithms used to allocate healthcare resources or predict patient risk have been found to disadvantage minority patients. For example, a study revealed that an algorithm widely used in U.S. hospitals to identify patients in need of extra care was less likely to refer Black patients than white patients with similar health needs, highlighting the potential for AI to exacerbate healthcare disparities. These are just a few examples of the pervasive nature of AI bias. They underscore the urgent need for greater awareness, robust regulation, and a commitment to developing and deploying AI systems that are fair, equitable, and accountable. Section 6. The challenge of fairness. Navigating the complexities of algorithmic justice. As AI systems become increasingly integrated into our lives, defining and achieving fairness in their application becomes paramount. However, this pursuit is far from straightforward, fraught with ethical complexities and practical challenges. A fundamental hurdle lies in the very definition of fairness. There is no universally agreed-upon definition, and different conceptions of fairness often conflict. Some advocate for demographic parity, seeking equal outcomes across different groups. Others prioritize equality of opportunity, aiming for algorithms that do not discriminate based on protected characteristics but allow for disparities in outcomes based on individual qualifications. Still, others argue for predictive parity, striving for equal accuracy rates across all groups. The challenge lies in the fact that these definitions can lead to different and sometimes contradictory outcomes. For instance, striving for demographic parity might necessitate adjusting thresholds or criteria differently for different groups, potentially raising concerns about reverse discrimination. On the other hand, focusing solely on equality of opportunity might fail to address historical disadvantages and systemic barriers that continue to impact certain groups. Furthermore, even when a definition of fairness is agreed upon, translating it into a measurable and actionable metric for AI systems is complex. Data limitations, technical constraints, and the evolving nature of societal norms further complicate the pursuit of algorithmic fairness. Despite these challenges, striving for fairness in AI is not an impossible dream. It requires a multi-pronged approach involving collaboration between ethicists, data scientists, policymakers, and affected communities. We must develop robust frameworks for assessing and mitigating bias, promote data transparency and accountability, and ensure that AI systems are designed and deployed in a manner that respects fundamental rights and promotes a more just and equitable society. Section 7. Towards Fairer Algorithms, Promising Solutions and Innovations. While the challenges of AI bias are significant, they are not insurmountable. Researchers, developers, and policymakers are actively working on solutions and innovations aimed at mitigating bias and promoting fairness in AI systems. One promising avenue is the development of less discriminatory algorithmic models. These models are designed from the ground up with fairness as a core principle, incorporating techniques to identify and mitigate bias during the training process. For instance, researchers are exploring methods to de-bias training data, adjust algorithmic parameters to reduce disparities, and develop fairness-aware evaluation metrics. Another crucial aspect is increasing transparency and accountability in AI systems. This involves making the decision-making processes of algorithms more understandable and interpretable, allowing for greater scrutiny and identification of potential biases. Techniques like Explainable AI aim to provide insights into how algorithms arrive at their decisions, enabling humans to understand and challenge potentially biased outcomes. Furthermore, promoting diversity in the field of AI is essential. A more inclusive AI workforce representing a wider range of perspectives and experiences is crucial for identifying and mitigating biases that might otherwise go unnoticed. Initiatives to encourage STEM education among underrepresented groups and create more welcoming and inclusive work environments are steps in the right direction. Beyond technical solutions, addressing AI bias requires broader societal changes. We must tackle systemic inequalities, promote data literacy, and foster ethical data practices to ensure that the data used to train AI systems is representative and unbiased. This requires collaboration between governments, industry leaders, and civil society organizations to create a more just and equitable digital future for all. Section 8. The Urgency of Action, Why Addressing AI Bias Matters Now More Than Ever. The urgency of addressing AI bias cannot be overstated. As AI systems become increasingly integrated into our lives, their potential to perpetuate and exacerbate existing inequalities grows. We are at a critical juncture where the decisions we make today will shape the impact of AI on society for generations to come. Failure to address AI bias could have dire consequences. It could lead to a widening of the gap between the haves and have-nots, entrenching existing power structures and further marginalizing vulnerable communities. It could undermine trust in institutions, erode social cohesion, and stifle innovation by limiting opportunities for those unfairly disadvantaged by biased algorithms. On the other hand, addressing AI bias head-on presents a unique opportunity. By developing and deploying AI systems that are fair, equitable, and accountable, we can harness the transformative power of this technology to create a more just and inclusive world. We can leverage AI to break down barriers, empower marginalized communities, and unlock human potential in unprecedented ways. The choice is ours. We can continue down a path where AI reinforces existing biases and deepens societal divides, or we can choose a different path, one where AI serves as a force for good, promoting fairness, equality, and opportunity for all. The time for action is now. Section 9. Conclusion: Shaping the Future of AI, A Call for Fairness and Equity. The rise of artificial intelligence presents both unprecedented opportunities and profound challenges. As AI systems become increasingly intertwined with our lives, addressing the issue of bias is paramount. Failure to do so risks exacerbating existing inequalities, undermining trust in institutions, and jeopardizing the transformative potential of this technology. Achieving algorithmic fairness is not a simple task. It requires a multifaceted approach encompassing technical solutions, regulatory frameworks, ethical considerations, and a commitment to social justice. We must move beyond simplistic notions of objectivity and acknowledge the ways in which human biases can seep into even the most sophisticated algorithms. The journey towards fairer algorithms will require collaboration, innovation, and a steadfast commitment to equity. We must invest in research and development of less discriminatory models, promote data transparency and accountability, and foster diversity in the field of AI. Crucially, we must address the systemic inequalities and historical injustices that underpin AI bias. The future of AI is not predetermined. It is a future we are actively shaping through the choices we make today. Let us choose to build an AI-powered future that is fair, just, and equitable for all. Let us ensure that these powerful technologies serve as tools for progress, not instruments of oppression. The time for action is now, and the stakes have never been higher.